Electromagnetic radiation. It consists of radiation of all sorts of wavelength and travels through space with the same speed but differ in frequency and wavelength. Note that the speed of light is equal to 3 times 10 to the power of 8 meter per second. So, these are the wavelength and radiation type. So, the radiation type of gamma rays have wavelength of 1 times 10 to the power of negative 12. For X-ray, the wavelength is 1 times 10 to the power of negative 10 meter. For UV and visible light, the wavelength is 1 times 10 to the power of negative 9 meter. For microwave, the wavelength is 1 times 10 to the power of negative 2. For TV and radio wave, it's 1 meter for the wavelength. Spectrum is a range of electromagnetic radiation with respect to its wavelength or frequency. There are two types of spectrum: continuous spectrum and line spectrum. In continuous spectrum, it's a spectrum of radiation that contains of all wavelengths. No definite line, so that's why it's named as continuous, that separate the colors. No definite line that separate the colors. For example, rainbow. Secondly, line spectrum, a spectrum of radiation that consists of discrete lines of specific wavelength. For example, hydrogen spectrum. There are two types of line spectrum: emission spectrum and absorption spectrum. This is the example for sodium emission spectrum, and this is the example for sodium absorption spectrum. So what you can see in emission spectrum cannot be seen in the absorption spectrum, and vice versa. So you can see different wavelength produce different color of spectrum. Hydrogen spectrum consists of discrete lines of specific wavelength. It's a line is formed when an electron drops from a higher level to a lower level. The discrete line reflects that energy is quantized, or the energy has specific value. This is the example of the formation of hydrogen spectrum. The energy is supplied to the hydrogen gas in the discharge tube by the high voltage. The electrons of the hydrogen atoms absorb energy and excite to a higher level. At the excited state, electrons are unstable, so they fall to a lower levels and produce radiation in the form of photons of a specific wavelength. Lights with a specific wavelength fall on the photograph plate, and the lines are recorded as the line spectrum. This is an example of atomic hydrogen emission series. For Lyman series, if the electrons at the energy level of 2, 3, 4 and above falls onto the first energy level or the first orbit, the spectrum region is ultraviolet and the series name is Lyman series. And if the electron falls from the energy level of 3, 4, 5 and above to n equal to 2, the second energy level, so this is the energy level of the final, it's Balmer series, and the spectrum region is visible or ultraviolet. And if the electron falls from the 4th, 5th, 6th and above energy level onto 3rd energy level. The series is called Passion series. And same goes to the bracket series. The final energy level is 4th energy level. P-fan, the final energy level, is 5th energy level. And all those are infrared spectrum region. The energy level for hydrogen atom. The transition of electrons that result in the formation of Lyman, Balmer, Paston, and bracket series can be shown by using energy level diagram. So the energy level diagram for Lyman, Balmer, Paston, and bracket. For Lyman series, electrons can fall from the 2nd, 3rd, 4th, and above onto the 1st energy level. It's called Lyman series. And for the Balmer series, electrons falls from 3rd and above onto the 2nd energy level. For Paston series, electron falls from 4th and above onto the 3rd energy level. For bracket series, the electrons fall from 5th and above on the 4th energy level. So we know that delta E is equal to Planck constant multiplied by nu, the frequency, equal to Planck constant multiplied by the speed of light over the wavelength. So this is the line spectrum for Balmer series. When the electron falls from the 3rd energy level onto the 2nd energy level, it produces 656.3 nanometer of wavelength. And from the 4th energy level to the 2nd energy level, it produces 486.1 nanometer wavelength, and so on. So as you notice, the bigger the change in energy, the lower the wavelength. Rank the following photons in terms of increasing energy. Increasing energy means decreasing in wavelength. So you have to put in order of decreasing the wavelength. So the first one is the highest wavelength, the red one, and then yellow, and then blue. Describe the transition of electrons that lead to the formation of lines W and Y respectively. To answer this question, you must know how to read the line spectrum. So this is the line spectrum for Balmer series. In Balmer series, the ground state of the electron is at n equal to 2. So the first line means the electron falls from n equal to 3 to n equal to 2. So the second line means the electrons fall from n equal to 4 to n equal to 2. And y is the fifth line. So it means the electron falls from n equal to 7 to n equal to 2. Then you have to identify which line is the first line for the Balmer series, this one or this one. So if you notice from the left side, as it goes on to the right side, the lines becomes closer. If you have a look at this, for this electron emission from n equal to 3 to n equal to 2, it produces this line. And the energy is bigger. From n equal to 4 to n equal to 2 has higher delta E. From n equal to 5 to n equal to 2 have higher delta E than this line. And the final one, n equal to 6 to n equal to 2 have higher energy than these three. So if you notice, the lines becomes closer. So the first transition is n equal to 3 to n equal to 2 is the line on the left because it is the furthest from the other lines. For this Pastian series, the line spectrum you have to read from the right because the lines become closer as you go to the left. So the first electron emission is this one. Which of the line in the Pastian series corresponds to the longest wavelength of the photon? Longest wavelength means smallest delta E. So smallest delta E is this one. In Pastian series, the electron falls from the fourth and above energy level onto the third energy level. So this line means the electron falls from n equal to 4 to n equal to 3.